Quick, graph y equals 1/2 times the absolute value of x plus 3 by hand 2 different ways. This is part of the Family of Functions series. You will need graph paper, or you can download this PDF and print it, and press pause as needed anytime during this video. First way, we need to decide what the parent function is and its shape. In this case, it's the absolute value function, and it's a V shape. This is our traditional parent function, absolute value of x. Keep thinking that mentally, that shape. Identify the parameters, and by that we mean values in the expression that affect the graph. There are 2 parameters here. And how do they affect the graph? Well, the plus 3 shifts all points up 3, and the 1/2 coefficient multiplies each y value by 1/2. What do we consider first? Well, we suggest plotting the vertex first, and neither of the parameters affect the x value, so it will stay at 0. But for the y value, we need to multiply by 1/2 and then add 1 according to the order of operations. Multiply, then add. So 1/2 of the 0, where it normally is, plus 3 is 3. So our vertex is going to be at 0, 3, and we'll plot that. Now we do the parabola dance relative to the vertex. Instead of right 1, up 1, we're going to go right 1, up 1/2 because of this coefficient of 1/2 multiplying each y value by 1/2. Instead of right 2, up 2, it'll be right 2, up 1, halfway up. Instead of right 3, up 3, right 3, up 1.5 or 3/2. So go ahead and do the left side there, pause, and press resume when you're ready to go on. Instead of left 1, up 1, it'll be left 1, up 1/2. Instead of left 2, up 2, it'll be left 2, up 1. And instead of left 3, up 3, it'll be left 3, up 3/2 because of that 1/2 factor. Connect the points, thinking about that absolute value V. The vertex is at 0, 3. There is an axis of symmetry. It's the y-axis, or the line x equals 0. And also we could talk about the slopes of the V, so to speak. They're both 1/2 and -1/2, and that comes from that coefficient. So this one's going uphill, slope is 1/2, and this part of the V has a slope of -1/2. Compared to the parent function, and you can see that it is wider than the parent function, and the vertex has been moved up 3. Using a table the second way, here are 5 points on our regular absolute value graph. None of the parameters affect the x values, so we can use the same x values as we did. However, the other 2 parameters affect the y values, 1/2 and positive times 1/2 and plus 3. So by the order of operations, we do the multiplication first, addition second. So 2 times 1/2 is 1 plus 3 is 4. You can see that calculation here if you need to pause. So we plot the point 2, 4. Multiply by 1/2, add 3. 1 times 1/2 is 1/2 plus 3. Think of 3 as 6/2. So we get 7/2. So we'll plot right 1, up 3.5. We suggest that you complete the table, pause and complete the table, press resume when you're ready. Zero times 1/2 is 0, plus 3 is 3, so we plot the point 0, 3. And the other points we actually have done up here, these values here, so it's going to be, but in this case it's going to be plotting -1, 3.5. And the second one will be -2, 4. Connect the points. Get our absolute value V. Compare it to the parent function. Again, it is wider and shifted up 3. Now you try one. Graph y equals 3 times the absolute value of x minus 4. Use either method or both for the practice. Press pause to do this and resume when you're finished to check your answer. And here is your answer, along with the table with the parent function and the one you're asked to do.